Hello, welcome to the fourth and the last in our series of videos where we solve the questions in the WASSCE 2020 Dec Elective Maths Paper 1. We have here question 31. In this video, we're going to solve questions 31 to 40. Question 31 says, a committee consists of 6 boys and 4 girls. In how many ways can a subcommittee consisting of 3 boys and 2 girls be formed if one particular boy and one particular girl must be on the subcommittee? So we have 6 boys, 4 girls, and we want to know in how many ways a subcommittee, so another committee consisting of 3 boys, so 3 boys and then 2 girls. We want to form a committee with 3 boys and 2 girls. If one particular boy and one particular girl must be on the subcommittee. So we can draw the slots for the 3 boys, 1, 2, 3, and then the slots for the 2 girls, we have 1, 2. So these are the slots that we have to fill. But then we're told that one particular boy and one particular girl must be on the subcommittee. So it's like you can imagine that this slot is already taken by that particular boy, and then this slot is taken by that particular girl. So in effect, we have 2 slots to fill, this and that. And how many people do we have to choose from to fill these 2 slots? We started with 6 boys, but one particular boy has already been taken out and put here. So we are left with 5 boys. We have 5 boys to choose from. 5 boys remain. Similarly, we started with 4 girls, but we've put one particular girl here. So to fill this slot, we have 3 girls to choose from. So here too, we have 3 girls. 3 girls remain. So the question now is, if you have 5 boys and 3 girls and you're trying to find a committee that consists of 2 boys and 3 girls, how do you do it? Well, here the order doesn't matter. It doesn't matter. All we need is 2 boys. So in how many ways can we get 2 boys from a set of 5 boys? And the answer is 5 choose 2, or 5 combination 2. And then for each of those options, we have to fill this slot for the girls. Now we have 3 girls and we are trying to fill 1 slot. So in how many ways can we do it? It's 3 ways. You can also write it as 3. This is the same as 3 combination 1. But the reason I wrote 3 is because it's easy to see that if you have 3 girls, call them A, B, and C, and you're trying to fill only 1 slot, then either you choose A, or you choose B, or you choose C. So if you choose A, that's 1 way. If you choose B, that's number 2. If you choose C, that's number 3. So those are the 3 ways. So we evaluate 5 combination 2 times 3. And what is 5 combination 2? 5 combination 2 is equal to 5 factorial over 5 minus 2 factorial times 2 factorial. And what is that equal to? That is equal to 5 times 4 over 2, which is equal to 10. So we have 10 times 3, which is 30. That's our answer. All right, the next question says, find the equation of the axis of symmetry of this curve. Y equals x squared plus 8x minus 3. Now, this is a quadratic, so its curve is going to look like this because the coefficient of x squared is positive. So it's going to be concave upwards. Now we are trying to find some imaginary axis here that divides this thing into 2 equal parts. And how do we proceed? If you remember the formula, if you will, or the rule, whenever you have a parabola or a quadratic like this, the midpoint, the axis of symmetry occurs at the point where x equals minus b over 2a. This is an important fact to remember. And so if you know that, then you know that the axis of symmetry is going to be, what is b? Our b is 8. So we have x equals minus 8, and our a is 1. So minus 8 over 2, which is equal to minus 4. So that's going to be our axis of symmetry, if you remember your formula. But if you don't remember your formula, what are you going to do? You can think of it this way, that at the axis of symmetry, or if you like, the axis of symmetry is going to pass through the minimum. So the minimum point on this curve, we're going to have the axis of symmetry passing through that point. So if we can find the minimum, then we can proceed from there. So we can differentiate this function dy dx. dy dx is 2x plus 8. Now at the minimum, dy dx is going to be equal to 0. So dy dx at the minimum is going to be equal to 0. That means that 2x plus 8 is equal to 0, and that means that x equals minus 4. So we found that the minimum occurs when x equals minus 4. And if the minimum is occurring when x equals minus 4, then what is the equation of a vertical line that passes through the point x equals minus 4? And that's precisely this point, this line, x equals minus 4. So those are two ways to do it. There are other ways to do it, but we won't cover them in this video. We'll do them another time. The next question is, find the area enclosed between the curve that and the x-axis, x equals 1 and x equals 2. So we have our boundaries. Again, this curve is going to look something like this because it's a parabola. This is a quadratic, and the coefficient of x squared is positive. A quadratic is always going to look like this or like that, and it depends on the coefficient of x squared. If the coefficient of x squared is positive, then it's going to be this way upwards. If it's negative, then it's going to be concave downwards. So this is it. Now we need to know where the x-axis is. Is the x-axis below this curve? Does it cut this curve, or what does it do? We can do so by finding the discriminant. The discriminant, remember, when you write the quadratic formula, there is something under the square root, b squared minus 4ac. This is called the discriminant, the b squared minus 4ac. And this discriminant determines the nature of the roots, whether you have two real roots or one real root or no real roots. And when you don't have real roots, it means that your curve is not going to cut the x-axis. If you have two real roots, then your curve is going to cut the x-axis at 2 points, and if you have only one, then it's just going to touch it. So let's find b squared minus 4ac. We have minus 3 squared minus 3. Let me rewrite this. Minus 3 squared, and then you have minus 4. Our a is 1 and our c is 5. So we have 9 minus, what is 4 times 1 times 5? 20. So this number is equal to what? Is equal to minus 11. And this is negative. It means that our function or our curve is not going to touch the x-axis. It doesn't have real roots. So our x-axis is going to be below the curve like that. And if it is, then the next question is, where is x equals 1 and where is x equals 2? Well, x equals 1 is always going to be at the left of x equals 2. So we can draw a sketch like this. I mean, this is not perfect, but you get the idea. The idea is that, so let me put it here. I don't want it to be the same. All right, so we have, this is the curve. This is x equals 1. This is x equals 2. Let me get rid of this. It's distracting. And then this is the x-axis. So this is the area we're looking for. Now, how do we find that area? In this case, we are lucky. We can find the area by setting up the integral. The integral is just going to be 2x squared minus 3x plus 5 dx. And we're going to integrate from x equals 1 to 2. And that's going to give us the answer. Well, the reason we had to go through all this trouble was that depending on the shape of the curve, things could have been a little different. For instance, if the curve was like this, and x equals 1 and x equals 2, this was 1 and this was 2, then you can see that the area enclosed between the curve and the x-axis, you have this one, and then between x equals 1 and x equals 2 also will let you you have to include this one, and then this one. So in this case, you have some of the areas being positive, these two, and then some of them being negative, this one being negative. So just setting up the integral this way and going ahead is not going to give you the result you want, because even though this area is negative, you want it to have a positive contribution towards the area. So you have to know the nature of the area you're dealing with, and that is why we had to go through this process. All right, so what do we get when we integrate this? Well, 2x squared, how do we integrate it? You increase the power of x by 1 and you divide by the new power. So we get 2 over 3 times x cubed. Then you get minus 3 over 2 x squared. Then you get plus 5x. And then you put your limits in. So you put 2 in, what do you get? You get 2/3 times 8. What's 2/3 times 8 is 16 over 3. So 16 over 3. Then you put 2 here. You have 2 squared is 4. 4, 3, 12. So 12 over 2, that's 6. So minus 6. And then you put 2 here, you have plus 10. So this is one term. The other is what happens when you put 1 here. You have 2 over 3. 2 over 3 minus 3 over 2 plus 5. So you have to simplify this. Let me get a bit more space. We have, what does this give us? Well, 16 over 3 is there. We have minus 6 plus 10. That together gives you plus 4. And 16 over 3 is, you can write it as 5 1/3. So 5 1/3 plus 4, that gives you 9 1/3. We'll come there, but then at the same time we have 2/3 minus 3/2 plus 5. What is 2/3 minus 3/2? We can write the 2 over 6. If you write it over 6, then 2/3 becomes 4, and then 3/2 becomes 9. So you have minus 5 over 6. This is equal to minus 5 over 6. So minus 5 over 6 plus 5 is going to give you 4 1/6. So we have 4 1/6. Okay, so 5 1/3 plus 4 minus 4 1/6. What does that give us? It gives us this 4 and this 4 are going to cancel, so you're going to have 5 1/3 minus 1/6, which is going to give us 5 1/6. So looking at the answers already, we can see there is this 5 1/6, and that's the result. The next question, so let me bring back into view the question, but the next question is question 34. Given that mu equals the integers from 1 to 10, and p is all x such that x is prime, so mu is our universal set, so p is going to be the set of prime numbers in that set. We can start listing them. There is 2, there is 3, there is 5, there is 7, and that's it. And then we have q is the set of odd numbers in that set. So there's 1, there's 3, there is 5, there is 7, there is 9. And we're supposed to find p complement intersect q. So p complement is all that is outside p. Let's write that for convenience. P complement, all that is not in p but is in mu. So all the numbers from 1 to 10 that are not in p. We have 1, we have 4, we have 6, we have 8, we have 9, we have 10. So how does this set intersect q? We want the elements that are in both of them. There's 1, which is in both. There is 9. 3 is not in that. 5 is not in that. 7 is not. So we have 1 and 9. That gives us this as our result. The next question is question 35. It says a contractor has tendered for 2 independent contracts. It is estimated that he has a probability 0.4 of obtaining contract X. So let's call the probability of obtaining contract X as Px, or P of X, and let's call that 0.4 as the question says. And then he has a probability 0.1 of obtaining contract Y. So the probability of Y, we write it as 0.1. Calculate the probability that he obtains exactly 1 contract. If he obtains exactly 1 contract, it means that he gets 1 and not the other. So either he gets, we can write it as he gets the probability of X and not Y. That's Y bar. Or he doesn't get X, not X, and Y. He gets Y. So this is what we're looking for. Now, these two events, they are mutually exclusive. How do we know that these two events are mutually exclusive? Well, this is the intersection of X and not Y. And then this is the intersection of not X and Y. Can there be an intersection between this one, X and not Y, and not X and Y? The answer is no, because if you have X and Y, or X intersect Y here, and here you are saying not X, so the complement, X and X complement do not intersect. So these two sets cannot intersect, or these two events cannot intersect. Similarly, you can do the same argument with Y. On the left side here, we are intersecting Y complement with something, but then on the right, we are intersecting Y with something. Now, Y and Y complement do not intersect. Therefore, these two events do not intersect. What that means for us is that these probabilities are actually going to add. So we have P, X, and not Y is going to add to this not x and y. Now the two events are independent. That's what they meant by independent contracts, but they lead to independent probabilities. So what that means is that now we want the probability of x times the probability of not y, and then we'll add that to the probability of not x times the probability of y. So we have to substitute some values here. We have probability of x. The probability of x we've been given as 0.4. The probability of not y is going to be 1 minus the probability of y. So this is 0.9, 0.9. And then we have the probability of not x. Not x is going to be 1 minus the probability of x. So we have 0.6 times the probability of y, which is 0.1. So we have to find the sum of these quantities. This is 0.36, and then this is 0.06. Adding the two gives us 0.42. So we have A. The next problem is 36. It says an object is thrown vertically upwards from the top of a cliff 20 meters high. So the cliff, we have a cliff first of all. If this is our cliff, a kind of plateau, is 20 meters high. 20 meters with a velocity of 25 meters per second. Find the times in seconds when it is 20 meters above the cliff. So here we throw an object, it goes up, reaches some maximum point, and then it comes down by the same path, if you will. But maybe to visualize it, we can think of it as going in an arc, but really it's going up to its maximum point and then it's coming down. Because it says it's thrown vertically, it doesn't really go through an arc like this, but if I draw it vertically, it will be difficult to imagine. But the ball just goes up straight up and then straight down. And we are trying to find, there is going to be a point at which it is 20 meters above the cliff. So from this point to the cliff, to the ground on the cliff, is going to be 20 meters, and that's what we're trying to find. Now here we can use an equation of motion. We've been given an initial velocity and we're thinking about getting distance. So we can use the equation of motion that says s equals ut plus half at squared. You have to know the equations of motion by heart. This is one of them. There's another one, v equals u plus at, and then there's another one, v squared equals u squared plus 2as. So these are the three equations of motion, but we're going to use this third one in this example. Now the distance we are interested in is 20 meters. So there is a time when it is 20 meters from the ground, which is its starting point. So this 20 is equal to ut. U is 25, our initial velocity, so 25t, and then plus half at squared. This acceleration, we got to pay attention here, because the object is thrown down, it's thrown up, is going to act against this acceleration due to gravity, which is g. So in this case, g is actually negative, so we have minus half. So our a is this g, which is 10, so 10t squared. Yeah, again, when you throw the object upwards, its velocity is acting in the upward direction, but the acceleration is acting in the downward direction. That's why it keeps decelerating. So we have to negate acceleration in this case. Now this gives us an equation. We have 20 equals 25t minus half of 10t squared. We can multiply through. We'll get 20 equals 25t minus 5t squared. Now we see 5 running through. We can divide through by 5. We get 4 equals 5t minus t squared. This is a quadratic in t, so we can write it out more nicely. If we will, we can write 0 equals t squared. So don't get confused by what I did. I just I'm moving everything to the left, but I've decided to write the 0 on the left, so everything is being moved to the left. T squared when it's moved to the left, sorry, minus t squared when it's moved to the left, we have t squared. 5t when it's moved to the left, we have minus 5t, and then the 4 stays on the left, so we have plus 4. And now we have to factorize. What do? We can do t minus 4t minus 1. T minus 1. That means that t is equal to 4 or 1. All right. So this is telling us that when the object is or if you like 1 second after the object is thrown, it is 20 meters above the cliff, and also 4 seconds after the object is thrown, it is 20 meters above the cliff. That is we can check if that is indeed the case, so let's do that. 1 second after it is thrown, how do we find the distance? We can use this. We know S equals ut. U is 25, so 25, t is 1, plus, but here we have minus half times 10 times t squared, which is 1 squared. So we have 25 minus, this is 1, this is 10, so half of 10 is 5, so we have 20 in that case. So that is right. We know that 1 is one of the options. Let's check with 4 as well. So we have S. Let me clean this. Okay. So we have this S equals U, again 25, then T, this case T is 4, minus half AT squared, so half 10 times T squared, which is 4 squared. Now what is this equal to? 100 minus 5 times 4 squared. 4 squared is 16. So what is 5 times 16? That's 80. So we have 100 minus 80, which is 20. So in both cases, we get 20, and we can be quite confident of our answer. The next question is question 37. It says the length of a rectangular object is 2 times its breadth. So we can draw a picture. We have the length and the breadth. If we call the breadth b, then the length is twice that, so the length is 2b. If the area of the object changes at the rate of 16 centimeters squared per second, when the breadth is 8 centimeters, calculate the rate of change of the perimeter. So we have to write a couple of formulae. The first one is P. The perimeter is 2 times length plus breadth. So this is equal to 2 times, okay, let me write it, 2 times 3b. This is equal to 6b. And then we have the area. The area is equal to 2b times b. That's the length times the breadth, which is equal to 2b squared. And we've been told that dA dt, dt, let me write it properly. dA dt is equal to 16. I'll ignore the units for now. That is when the breadth is 8. So dA dt when b equals 8 is 16. And we are supposed to find the rate of change of the perimeter. That's dP dt. So here we can write a formula for dP dt and then see how we can use it to get our answer. Now we are looking for this dP dt when b is equal to 8. So b equals 8. And what do we have? Well, this is the formula we have for p. P equals 6b. So dP dt, we can write dP dt as dP dB, and then we dot that with dB dt. And what does that give us? dP dB is 6, and then dB dt is something we don't know yet. We're here to find out what dB dt when b is equal to 8. We're here to find that. But we also know that dA dt, so dA dt, which we know a to be 2b squared, but dA dt can be written as dA dB dot dB dt. So this dB dt, so this dB dt we didn't know has appeared here too, but the difference is now we know dA dt when b equals 8. dA dt is 16, and dA dB is 2, well, the derivative of this with respect to b, so we have 4b, and then dB dt is what we're looking for. Now we've been told that this 16 happens when b is equal to 8, so we can substitute b equals 8 here. Then we have 16 equals 4 times 8 is 32, so 32 dB dt. So 16 equals 32 dB dt. What does that mean? It means that dB dt equals 16 over 32, which is half. So over here we can substitute this dB dt equals half into this, and that gives us 6 times half, 6 times 1 over 2, which is equal to 3. So that's the answer we're looking for right there. The next problem is question 38. We're supposed to find the range of values of x for which this function g of x is increasing. We first find the derivative with respect to x, so g dashed of x is equal to 3x squared plus 12x. And now we want to set this to 0, because for the function to be increasing, its derivative must be greater than 0. So actually what we are looking for is not g of x equal to 0. We are looking for g of x greater than 0. Let me write it properly. Let's get that. No, we get that. All right. Okay, so we want g dashed of x greater than 0. That is when it's increasing. So we write that inequality 3x squared plus 12x greater than 0, and then we solve it. This is a quadratic inequality, so we solve it as usual. The way we solve quadratic inequalities, we have 3x times x plus 4 is greater than 0, and then we have the roots. The roots are x equals 0 and x equals minus 4. And then I like to draw a graph. I know that when I have a quadratic which has the coefficient of x squared being positive, this is the shape. And I also know the roots. We know that if this is equal to 0, the roots, let me call it the roots are 0 and minus 4. So this is minus 4 and this is 0. And I'm looking for when this thing is greater than 0. In other words, when it's above the x-axis. This is precisely the region. So we have here, let me draw with a different pen, this direction from here going, but it doesn't include the 0 because it's a strict inequality. And then we have in this direction. So this gives us x greater than 0 or x less than minus 4. So let's see, x greater than 0, x less than minus 4. That'll be this. So that's our solution. Actually this and this or should be end, because we are looking for the entire region or the set of regions in which it's increasing. So it's the intersection, not the intersection, sorry, the union of all of this. So when this is the case, and then also when this is the case. Well, let's go to the next question, question 39. Question 39 says evaluate this. Log to the base 2 of 4 over log to the base 3 of 27 minus log to the base 5 of 25. Now here we just have to substitute the values. Log to the base 2 of 4 is 2. Now when you have log to the base something, let's say it's the base 2 of 4, and you want to know what it's equal to, you're basically looking for that number to which you must raise 2 to get 4. So it's basically, the question is the same as 2 to the power x equals 4, and then find x. So here log to the base 2 of 4 is 2, log to the base 3 of 27 is 3, and then log to the base 5 of 25 is 2. So what do we have? We can write this over 3. We have 2 minus 6, and that gives us minus 4 over 3. So that gives us that. The next is question 40, and that's our last question in this video. It says, given that P and Q are the statements P, the girl is crying, Q, the dog is barking, which of the following represents the girl cries if and only if the dog barks? Now, if and only if is a two-way implication. When we have an if, the implication goes in this direction. But in an if and only if, it goes in this rightward direction, but also goes in this direction. So if and only if means that the two are equivalent. So this statement is going to be on the left, this statement is going to be on the right, and we have an if and only if between them. So the girl cries, that's basically P, even though here they have the girl is crying. And then here the dog is barking, that's our statement Q. And then between them we have an if and only if. So that gives us this one. But one thing to know is that when you have a statement like this relationship between them, this if and only if relationship is symmetric. So if you have P if and only if Q is the same as Q if and only if P. So I'm bringing it up because I see that A is also just like that. So even though in this statement P comes first and then Q comes second, because if and only if is symmetric, so that you can also write Q if and only if P, you should be able to select A as well. So I guess here there are two answers. I mean, this is just like multiplication. You can write P dot Q, but that's the same as Q dot P. Or if you want a different one, it's like equals. When you write A equals B, is the same as writing B equals A. So that's exactly how if and only if works. So you can choose B, you can choose A. All right. This brings us to the end of our video and also to the end of our series where we solve the questions in the 2020 WASSCE Dec Elective Maths Paper 1. I hope you enjoyed it, and we're going to have other exams solved in other videos. See you later. Bye.